Okay, like I said, this is our last set of notes before the series quiz over series tests. That doesn't sound confusing. Okay, these are our last two tests. Tomorrow I will give you a flow chart of all of the different series tests. Okay? Tomorrow. First one is the ratio test. The ratio test, Mrs. Holman's favorite.
Why is it your favorite?
I don't know. I like it. It's not the. You really think that I would choose the hardest one to like the most?
Yeah.
Okay. Fair enough.
You're a math teacher.
I am a math teacher. Okay, so we have a sum of the sequence of non-zero terms.
Yeah.
If we take the limit of the ratio a sub n plus 1 over a sub n, absolute value, and it's less than 1, then it converges. What do you think the second stipulation is? Then it diverges.
I flipped. I had A of M over. Yeah, that's right. Yeah, that's right. Is that the third one?
What?
Just use you're saying A of M over A of M plus 1
Would be less than 1.
greater than 1. Greater than 1 would make converges.
Oh, I see. Okay. Well, we're just going to keep it the same as to not be confusing. Okay? We're going to keep it as a sub n plus 1 over a sub n. If that limit is less than 1, it converges. If it's greater than 1, it diverges. One more thing to take into account. Do you see equality anywhere?
Actually, the other way might. I know it would be 0 terms.
Inconclusive if the limit is 1.
Mike is a word.
What did you say?
I was like, if they're equal, then it doesn't.
We just can't use it. I like this one, but it doesn't work 100% of the time. Still probably no. Okay. Because he plays basketball often. Now, I will say that the ratio test, okay, it's not as much work as the integral test, but it is more work than like the direct comparison test, right? So I wouldn't try to use this all the time, but I would try to use this on the wacky ones. And what do I mean by the wacky ones? This guy right here, perfect candidate for the ratio test. So the ratio test, we are going to take the limit as n approaches infinity of a sub n divided by a sub n. Are you okay with me dividing by just multiplying by the reciprocal?
Absolutely.
Sorry. Jake, did you have a question? Okay. So what I would do is I would group things together. Okay? I would group the 2 to the n plus 1 over the 2 to the n together. And then I would group n factorial over n plus 1 factorial. Okay? That way we can simplify. Now, more than likely, this is a step you're going to do in your head, but I'm trying to organize it now for you to see. Okay? 2 to the n plus 1 over 2 to the n. 2 to the n plus 1 over 2 to the n.
It's be greater than 1. It's be less than 1.
2, okay. We have the same base.
Yeah.
We're dividing. What do we do with our exponents? Okay?
So we have to get 2 to the n. It's greater than 1. It's greater than 1.
Okay? N factorial over n plus 1 factorial. We have an n plus 1 in the denominator. Right, Isaac?
Yeah.
The limit goes to 0, which is less than 1. So it converges by the ratio test.
You can use that for the absolute thing when you're doing like the alternating series test.
Yes. So this
So the second
absolutely
step,
converges.
You just do 2 at one time. Means you have your like you do the limit and then you do the ratio test for the second step, right? Let's see if it's all, well, that's the series.
Right. Right. We have to be careful because it could equal 1. You know what I mean? But yes, this does mean it absolutely converges because we're taking the absolute value inside of our limit. Okay? All right. Next example. If you would have seen this 4 days ago, you would have been like, you still are?
No.
I'm not judging you, I'm just enjoying the music.
Okay, so pretty crazy, right? Anytime you have like exponential mixed with factorials or
Other forms of expert.
polynomial, yeah, I mean you have all sorts of stuff. Ratio test is a good idea to try. So we have the limit as n approaches infinity of, so n plus 1 here, divided by a sub n. Isn't that what I wrote? It's what I thought in my head, but I didn't write it. Okay, so, okay, n plus 1 squared over n squared, that's not going to be able to reduce, but we know what the limit is, okay? And then we know that we are going to have an extra 3 up top and an extra 2 in the denominator. Do you agree?
Yeah.
Thank you. What's the limit of this guy right here? This is 1. Our limit is 3 halves, which is greater than 1. So this diverges by the ratio test. One more example before our last test name. Who?
The limit is not
What?
either outside.
It's outside.
Divergence and
Isn't it around the wall?
It's been around the hall.
I just noticed it today.
Are you kidding me?
It doesn't
It's been there since October.
been up for a while.
Down there, it's still not attached on the plane.
I know.
It's been like that for a while.
I know. I need to get a ladder. Okay. Thoughts?
Divergence.
What? If we do the nth term test, what's the limit? Okay? Don't get caught up in a certain routine and think that all problems
I hit it
can be
with
solved that way.
every time. Every time.
What did he say?
I do the end-term test every time.
As you should. And I hope that that's why we got it so fast, is because you're in the habit of checking the limit before you try anything else.
Yeah. Yeah, we are.
Okay, so we did a little bit of R&R today. We did our ratio test, and now we have root test. Our root test. Okay, so this has the same rule, except for taking the nth root of our sequence inside the series.
Might go really well the first time.
Same rule, if that limit is bigger than one, it's going to diverge, and you guessed it, equals 1 inconclusive.
We don't like it when there's one.
Nope. There's your snow.
He bumped his head
That's good.
and didn't get up. That's a dark story.
Oh, I thought it was doing something.
I thought it was until the morning.
I thought it was in the morning.
He didn't get up in the morning.
Yeah.
Until
I thought he
morning.
didn't get up in the morning. He died.
Why would he get up in the morning?
The rain.
Wait, when he says he, does it say he bumped his head?
Bonk.
Bumped? Like he hit it?
Yeah.
Why? Why?
Why what?
Why did he hit his head?
I didn't pick the song up. I don't know.
Maybe you can sleep, so I just had not to about.
Okay, do we have this written down? That's what I'm waiting on. I would have moved on. Okay.
Okay. You want to hear where we ran yesterday?
What?
So we did a shelter loop. You know the shelter right up there. That's a mile. Then we did a mile down 108th Street to the bottom of the hill, and then back to the school. And then we did 2 laps around the school, and then we did another shelter loop. Then we did 2 laps around the school. Then we went down to the fire station, down 108th, and back, which was 2 miles. And then we did 2 more laps around the school.
What miles?
It was pretty good.
Yeah, we mixed it up.
And it was snowing on you. I bet it was nice and relaxing.
Or terrifying.
It was pretty nice, I think.
Yeah. Everyone was moving so slow.
Yeah, we had 9 minutes.
And then I got yelled at for going normal.
I had to push it.
Okay. Why is this a good candidate for the root test? Okay, basically, the only time you can use the root test is when you have your sequence raised to the nth power. So if you write this as e squared over n raised to the n power, which is the same thing as what that is, right? I just rewrote it. Now we can use the root test. Okay? So we take the limit as n approaches infinity of the absolute value of the nth root of e squared over n. Okay? And what's going to happen every time in that root test? The point of using it. The nth root and the n cancel out. So we have the limit as n approaches infinity of e squared over n, which is 0, less than 1, converges by the root test. Okay, go ahead and write this example down. Write this example down. I think that some of us are already going to be able to figure out where this will go before we even perform any sort of convergent series test. Is this a good candidate for the root test?
Yes.
Why? Because we have something raised to the n power. I mean, that's really what we have to look for. Okay? Now, if it were geometric, we'd be able to use the geometric. We could use the root test on a geometric series, but we might as well use the geometric test. Okay? So we have the nth root of 3n plus 4 over 2n to the n. Those cancel out, and we're looking at the limit as n approaches infinity of 3n plus 4 over 2n. What is that limit? 3/2, which is greater than 1. So we have a divergent series based on the lovely root test.
That was like up here. That was like up.
Okay, last example for the day. Last example for the day. Write it down. We won't call it a day, but it's the last example for the day. Okay. Can you see what's going to happen here? Grayson is saying that the root test is going to be inconclusive. Do you agree?
Yeah.
If we take the nth root of that, we get 1 plus 1 over n. The limit towards infinity is 1. It's inconclusive. Nth term test. Okay. Grayson, what is the limit as n approaches infinity of 1 plus 1 over n to the n?
1 to infinity, which is
1.
And it's correct.
1.
What?
Haven't we talked about this many times?
No,
Yes, we have.
I still don't.
No one's gonna remember.
Oh, you have to do all, you just have to do.
You would have to do L'Hopital's rule, but we've done L'Hopital's rule on this guy enough to where you can recognize this as E. Which is not 0. Now, if you don't recognize it as E, you just do L'Hopital's rule with a funky natural log, thing, but
Okay, that's what I
Or
was
this is
thinking.
Oh boy.
okay. Your assignment is on your gold sheet. We have 13 minutes. I would like you to get 4 problems done. You may begin.